Hi, everybody. This is a walkthrough video for the lab titled Simulated Methods to Estimate Population Size. This lab has a couple of activities to it, and even with activity one, there are a couple of sub-activities to just activity one. So this is a walkthrough so that you understand what you're doing when it comes to this lab. So before starting, you want to refamiliarize yourself with the metric side of the ruler and note where 10 centimeters falls on the ruler. So you should have had a ruler in your lab kit in the general supplies. And this is the same ruler that you hopefully have been using throughout the course. What I also want you to note is that the 10 centimeter mark on the metric side of the ruler is also equivalent to 100 millimeters. So 10 centimeters is 100 millimeters. This is going to become important because the lab kind of shifts the units on you. It talks about centimeters in the directions, but then it brings up millimeters in the table. You also want to locate where 0.5 centimeters is, and 0.5 centimeters is equivalent to 50 millimeters. So that is important when looking at your ruler. And if you choose to use a different ruler for the lab, one that you have at your house, you want to make sure that it has a metric side to it and that you're not just looking at the standard or English type of ruler. Okay, so in your lab, you've been given this big sheet that has a lot of colors on it. And as you read the directions for activity 1A, it says that you need to make 5 random transects of 10 centimeters, again, 100 millimeters, in your population map. I did this on my map. You can see my 5 areas. Yours can be totally up to you. I used a fine tip dry erase marker. I realize they're not available for everybody to use. Some of the expo markers that you can get have thicker tips on them. I used a fine tip one and I still made a pretty thick line. So you are going to have to be doing some sort of a little bit of guesswork when it comes to looking to see what colored squares did your lines actually go through. So it says if your lines are a bit thick, do your best to see what squares the lines actually went through. So these squares are very small and they're in different colors, and you want to be able to see your transect line, what color squares did it actually go over or touch? So as you are filling out the transect data table, you'll see that there is 5 areas of the table because there's one for each line. So there's transect 1, transect 2, transect 3, 4, and 5. The first time you look at this, you're going to be filling out information for trial 1 because that's the first time. So you are going to do 2 trials of this, but the first time is going to be trial 1. When you take a look at this table, like I said, it goes into millis instead of centimeters. So just, realize that even though it says 100 centimeters all the way down, 100 millimeters all the way down at the bottom, that really is 10 centimeters. So it says, don't worry, 10 centimeters is equal to 100 millimeters. Fill out the table with the color names. So what I mean by that is when you go in, your point of 0 is where your line actually starts. And you want to, and I know this is going to be tricky, but you want to fill out as best you can what color is in that 0 mark. Okay, I'm trying to actually write it on this page here, but it's not really giving me the best option to do that. So instead of me actually writing out the name, I'm just going to indicate with a colored dot just for the purposes of this walkthrough. So let's say the 0 millimeter mark, and that's really the front of the line, the exact front of the line is going through blue. Then you want to indicate there that, there was a little bit of that it was going through blue. Okay. Let's say by the time you get to 5 millimeters or 0.5 centimeters, that's going to be your first dot. So you need to make dots every half a centimeter along the length of each line. let's say that that one went through a green square. Then you would write that there. So the trouble with this is obviously the thickness of your line, and even the thickness of my line using a fine tip marker, I was going through multiple squares. So even the lab tells you to just develop a criteria that you're going to use. So, pick a square. In other words, if you end up encompassing more than one color, and just be consistent with your technique. So, you are going to pick which color you saw the line go through for the whole length of the line, but it's every half a centimeter. And remember, half a centimeter is 5 millimeters. So that's why you see here, and I'm going to annotate this with my annotation tool. Like you can see 5 millimeters, 10 millimeters, 15 millimeters, 20 millimeters. So that is a half a centimeter. So going through the whole thing, you can kind of see how many marks you're going to have all the way up to the point that you have 10 centimeters. Okay, so it's kind of a lot of little dots, and those of you who may struggle with nearsightedness, this might be time to put on your reading glasses and, really look at these transects. I've had students tell me before, this is making me go cross-eyed. And it might be a challenge. And, if you're getting a little bit of eye strain from it, then take a break from it. You may also have a magnifying glass in your lab kit's general supplies. I want to say that there's been times where they've packed in a magnifying glass. So you could also look for that. But yeah, the biggest struggle here is just trying to see everything. So once you get done the first trial, you are going to completely erase every line on the board. So I'm going to come in and erase all my marks here. And if I show you the board again, okay, I would go in, I would erase my 5 lines that are here, and I would draw 5 brand new lines. Totally different areas, brand new lines. Okay, and that is what we would call trial 2. So trial 2, you erase. That's why it's important for you to use a dry erase marker, because if you're using a Sharpie, you're not going to be able to get rid of it. So use a dry erase marker and wipe it off with a wet paper towel, or you might even be able to just rub it off with your finger. Okay, so that's 2 separate trials, and that is activity 1A. Table 2 is also for activity 1A. So what you're going to do is you're going to count how many times you saw blue for the first trial. So again, this is the separations here on the chart is that this area is for trial 1 and the other columns are for trial 2. So you're just going to count up how many times did you see blue in your first trial? That's all the lines. How many times did you see red? How many times did you see green squares? And then by the time you add them all up, that's going to be your total number of squares counted. And then you need to calculate percent cover. So percent cover, I have put the equation over here. Percent cover is the number of squares in one color. So if it's like your blue, over the total squares counted for all colors. Okay, the total number of squares counted for every single color. Okay, so just very easily, you would take your number that you're going to put here for blue, that would be your numerator, and your total number is your denominator, and that's going to give you a percent. Now, remember, with percents, it's going to give you a decimal first, and then you have to times it by 100 to get a true percent. Right. So to get a true percent, you would always multiply by 100 and then get your real percent. If you were to put in your decimal, that's fine. Like I'll understand it. But a true percent has been multiplied by 100. And then the other columns here are for trial 2. So that's your second trial. And all of this data for data table 2 is pooling from data table 1. Okay, so that's activity 1A. We're going to move forward to activity 1B. And for this one, I thought that reading it was pretty clear cut. You are using what's called quadrats. Quadrats, okay? To get a quadrat, they tell you to use your chenille stem, which is just a fancy name for a pipe cleaner. Like most of us know it as a pipe cleaner. So they packed you a pipe cleaner and you will need to cut it exactly how the lab tells you. Okay, so you can see it here. And then you bend it at right angles and you connect it to be basically a little square that's going to cover an area of 2.5 centimeters by 2.5 centimeters. So, that's why you need to have your ruler out again and make sure that you're cutting it and measuring it the correct size. So it says you will be using the pipe cleaner here, cutting it to size and bending it into a square as shown. So it needs to be like this. And you're only doing it with one, I believe, if I remember correctly. You're just doing it with one part of it. So let's see what you have to do here. You are going to be putting it around the chart. So you want to follow the directions as is. Like I said, I thought the directions for this were pretty clear cut. You want to put it onto the chart in a random spot. And once you put it in that random spot, you want to count how many red squares are in that area. The area itself is 6.25 square centimeters because it was 2.5 by 2.5. So the total area is 6.25 centimeters squared. You want to put down how many red are in that square the first time that you place it randomly. And then you want to put how many green are in that square. So you do that, you do each of those. Then you're going to take the square and move it to a totally new spot. So let's say in the first one, I'm putting a check mark here, and that might be a little bit misleading. You're not putting check marks. You are putting actual numbers. So let's say that you put in 10. Let's say there's 10 red ones. And then when you go to count the green, there's 5. And that's for square one or quadrant one. You're going to put the quadrant in a totally new area, and you're going to count the red and the green in that area. And so you're going to do this a total of 5 times. Okay. And to get the average, it tells you right here, to average the colors, you add each color and divide by 5 trials. So if I go back to my red, let's say I had 10, 8, 7, 12, and I don't know, maybe another 10. So I would add all of these together and then divide by 5, and that would give me an average number. And I would put the average here. Okay. Same for green. And then to get your final density, you want to actually do this equation here. You want to take your average number and divide by the 6.25. Okay, so you're actually going to run that in a calculator. Take your average number, which is going to be right here, divide by 6.25, and you're going to get your density in just 1 square centimeter. All right, so that's going to be a much smaller number. And then that's going to go in that final row of activity 1B. So I thought that activity 1B was pretty clear cut as to what you're doing. The hardest part probably just, again, counting the squares and maybe even folding the pipe cleaner a little bit. That can be a little bit of a challenge. So let's move on to the last one. Okay, so now you're going to be working with these small beads. So if you have pets or small children, please be aware that these, if you happen to be a little bit clumsy with them, like sometimes I am, they might wind up on your floor. And the last thing you want is for, a small child or a pet to be eating these. Of course, if they did, they're just made of plastic, but still there is a choking hazard to think of here. All right. So this is called mark and recapture. So this is simulating a mark and recapture. You can see that I got out a bowl and I have 2 cups. These are more like glasses, but I just grabbed what was nearby. And you're just going to follow the directions here. It tells you to put all of the white beads into the bowl. And then you're going to scoop out with your hand any number between 14 and 25. Now, I will tell you the first time I scooped way more than 25. Then I had to try it again, go smaller, and I ended up scooping out 22. So the 22 that I have is right here in the picture. You can see it right there. Okay, so that's my 22. Now, once you get that 22, you will be putting that into the data table. There's a little spot at the top of the data table, and I'll show you this in a minute. So you do have to put this number 22. Well, it's whatever number you get. My number was 22. Your number could be 14. Your number could be 15. Your number could be 25. But that number goes somewhere in your data table. So just hold that thought. Let's go to the next step. Oops, I skipped the step. Okay, so I took the 22 and then I put them into the cup. Okay, so if you put them in the cup, they are technically called captured. So you have captured those 22 out of your white beads. And you'll see that I put this cup off to the side in the next picture. So cup is now off to the side. I take my red beads and I have to replace each one of those 22 with a red bead. So I counted out 22 red beads and I put them into the bowl. So they are kind of like, they are marked. Like they technically represent a marked population because they represent the 22 that I had already removed one time. Okay, so my red are in there now with my larger population that was not captured. All right, so now I'm going to start sampling. I just sampled with my hands, and the lab does tell you you can't go above a certain number with sampling. So make sure you pay attention to what that number is. I put my hand in, and my first grab was of 23 beads. And only one of them was red. And I really like mixed it up and tried to make it random. So I only got one red. And since that was already a captured bead, that this time is technically called the recapture. So I have recaptured that bead. So to go into my data table, my sample 1 is going to be these 23 right here in my hand. That's my sample 1. I have one single marked bead. That's my red one. So my percent is going to be 1 out of the 23 times by 100. So we just talked about, when calculating percents, you have to multiply by 100. And therefore, my percent is going to be 4.34%. So, you can run that calculation on a calculator or on your phone, the calculator on your phone. So I'm going to clear this out and just show you what the data table looks like. So every single step moving forward is just going to be you grabbing beads. So all of these in my hand have to go back into the bowl. So my next step would be put them back in, mix them around, go for sample 2. Put them back in, mix around, go for sample 3. Put them back in, mix around, go for sample 4. So how many samples are we doing? Well, in your data table here, you can see that I want to say you do this close to 20 times. Like there's 15 that you can see in the table right here, but I want to say this data table goes to 20, but it'll go quick. It really will. So remember how I told you to hold that thought about how many beads I took out in the beginning, the white beads? Well, now I want you to remember that because the initial number of beads that I marked was 22. And remember, that's my number. So unless you are doing 22, you don't have to write 22. Like you write your number. Then when I went to do my sample, I captured 23. I had one that was marked. And then remember how I did the 1 over 23 to get my percentage, but I also multiplied this by 100. And it ended up being like the 4.3%. So just get in my sloppy rating here. That should be 4.3%. Okay, there we go. So remember that for sample 2, sample 3, sample 4, all the way to the final sample, you're putting the beads in your hand, back in, mixing them up, and just grabbing again. But there's a certain number that you can't go over in your grab. And I want to say it's like, it might be 40. I'm not sure. You know what, let's take a look. We can go back to the procedures. So here's the part of the procedure that I'm talking about. And it says right here that when you're randomly capturing, it needs to be between 25 and 40 from the bowl. 25 and 40. Okay, so make sure that you're getting enough. If not, get some more. If you got too many, just put some back. So let's talk about the deliverable for this lab. The deliverable is going to be all the data tables, and same rules apply that usually apply. You're either neatly filling them out using some kind of PDF annotator, or you can print them and write neatly in them. The only thing is when you print them and then take a picture of them, the picture really needs to be done well. You know, really capture the whole document in the photo. Sometimes when I've seen students submit pictures of their work, the work is like really far away or it's really fuzzy. Just make sure that you're double checking, and you can always send me a remind text of the picture first and say, can you see this? You know, because if I can't see it, I can't grade it. And if I can't grade it, that's obviously going to be a problem. So you can always ask me if I can see something. So your turn-in is right here. And I need data table 1, 2, 3, and 4. Okay, so, and I also need to spell check the word walkthrough here. So this walkthrough video will be found with the assignment. It'll be found hopefully right on the folder. Hopefully I won't have any more issues with putting stuff on the folder. And that's it for the simulated methods to estimate population size. Please make sure that if you have any questions, you contact me either through email, remind, or we can always do a one-on-one Zoom session. Thanks so much.